Most stars in the universe are stars that would cause the Earth to lose its atmosphere within a few million years. Our solar system is more unique than you might think. Of course, the most awkward fact is that this is the only system where we have found life so far. But this is not an argument. It is the beginning of our curiosity. Our Sun is classified as a G-type star. As you can see here, only about 8% of stars are similar to the Sun, and these are the most likely to support life in the form we know. For example, M-type stars, red dwarfs, which make up nearly 80% of all stars, are very unlikely to host life. They are much cooler, which means that planets must orbit extremely close to them. As a result, these planets are usually tidally locked, with one side constantly facing the star, while the other remains in permanent darkness. One hemisphere becomes extremely hot, while the other is cold and frozen. In addition, M-type stars are highly active and frequently emit powerful stellar flares and radiation capable of stripping planetary atmospheres. Stars that are larger and more massive than the Sun face a different problem. Their lifespans are simply too short. Life on Earth took nearly 4 billion years to form and evolve. F-type stars live for about 2 to 4 billion years. In theory, simple life could exist around them, but the emergence of intelligent life would be far less likely. A, B, and O-type stars live for even shorter periods, with O-type stars ending their lives as supernovae, as you can see right here, after only a few million years. This places us within that rare 8% of systems, orbiting a star that can sustain life in a stable way, without randomly destroying planetary atmospheres like a box of matches catching fire. But that is only the beginning. If we take a look at this table, showing how many planets orbit each discovered exoplanetary system, we can see that only one system has the same number of planets as our own. When we examine it more closely, we find that its central star is also a G-type star, very similar to our Sun. However, its most distant planet is still located closer than 1 astronomical unit, the distance between the Earth and the Sun. This means that all of its planets orbit very close to their star. And this is not an exception. On this graph, we can see that almost every planet we ever discovered is located closer than Earth to the Sun. Now let's look at the types of planets in the solar system. As you can see, there is a noticeable gap between Earth and Neptune. It turns out that the most common type of planet in the galaxy is completely missing here, the super-Earth. These planets typically have masses between 1 and 10 times that of Earth, and can be up to 3 times larger in radius. Here is an example, Kepler 1638, almost 2 times bigger than Earth, and over 4 times heavier. But don't let the name super-Earth fool you. Surface gravity on these worlds is often about twice as strong as on Earth. On such a planet, our civilization would struggle to reach space for a very long time. Launching satellites or building a GPS system would be extremely difficult. On Earth, about 85 to 95% of a rocket's mass is fuel. On a super-Earth, that value would exceed 99%. To put this into perspective, the Saturn V rocket weighed about 3,000 tons to deliver just 45 tons to the Moon. On a super-Earth, delivering the same payload could require a rocket weighing over 300,000 tons. When you add a denser atmosphere, frequent volcanic activity, and a likely lack of plate tectonics, such worlds become extremely hostile to life. Super-Earths make up more than 25% of all confirmed exoplanets, and when we include candidate planets, this number rises to nearly 30%, making them the most common type of planet discovered so far. And we must not forget our big brothers, Jupiter and Saturn. These gas giants act as gravitational shields, deflecting or capturing comets and asteroids that could otherwise end life on Earth. Their positions are just right, and such a configuration may be rare in other planetary systems. Another remarkable object is our moon. It is not the largest moon in the solar system, but relative to the size of its planet, it is enormous. Why is that? Today, over 90% of planetary scientists agree that about 4.5 billion years ago, another planet existed in a similar orbit to Earth. This Mars-sized body, called Theia, may have coexisted with Earth for millions of years. Eventually, their orbits became unstable, leading to a massive collision that ejected vast amounts of material into space, far more than the moon's current mass. After the impact, Earth was covered by a global ocean of molten lava. Over time, the debris formed the moon. Without it, Earth would not have stable seasons. Our planet's axial tilt would vary chaotically, making long-term climate stability impossible. In that sense, the moon is not just a companion, but a crucial factor in our existence. This is not just coincidence. This is a chain of rare events stacked perfectly together. And the question is not whether the solar system is unique, but how many times the universe was willing to roll the dice.